Is Amida Dosumo on this call? Amida Dosumo, is she on this call? Dosumo Amida. You're on this call, just give me a thumbs up so I can know you're on this call. Okay. So I want to believe that I explained to you guys everything relating to motion and the likes. So in our class today, we are going to quickly continue with circular motion and talk about everything that is related to circular motion. Is that okay? Although I asked you guys to do the work as an assignment because the last class I had a meeting and I had to like this guide class. So when we say circular motion, it is defined as the motion of an object around a circle or circular path. Now, when an object undergoes circular motion, this happens when that object is moving along a circular path at constant speed. Go ahead, Dosuma Amida. Go ahead, please. You have a
Some
question?
people are still on the group. Oh,
On the group?
yes.
What do you mean on the group?
Like the other group that we had before. Like Olawale, usual, what's his name? And one girl like this.
Oh,
I think
okay.
it's the English link.
That's the
That's
English
English
link
link.
now. You guys, the reason is because you guys don't read the instruction. You don't read. The error that we are now, you guys don't read the instruction. The instruction is very simple. We'll be using this link for our English class. That was what the English class said. But you guys are there clustering the group for Khadija, please go on that link and tell them that this is not the link they are using. Thank you. Are you with us, Khadija?
Sir?
Please go on that other link that 1 minute.
It is not our English spelling, Abby.
Yes, that English that link, yes.
Okay, sir.
So go to the link and tell the students there that all the students that are there, they don't used to read instruction. Because that instruction is very, very clear.
No, sir, no link for this class. That's why.
No, the link for this class has not changed. There was a reason why the link for the English class changed. There was a reason. People that joined the class that they knew the reason why the English class changed. The English link changed.
Yes, sir.
Okay, sir. I was there too.
Hey,
Okay. So when we say circular motion, it has three basic characteristics. The first is constant speed. I know why I'm saying all these things. Ojumiti Rio, I have seen questions. So these things I'm saying are important. Anything I'm teaching you now to the end of JAMB is very important. Now I'm not teaching things that are not important. I'm teaching stuff that are only important. You can see your math class. I did not even give you the definition of matrix, type of matrix. I just went to questions that JAMB will ask you. The same thing I'm doing in this physics class now. There's no need to be putting makeup anymore. Now is time for nikah. No need for makeup. Just do nikah and go out of your father's house. So constant speed, that's the first characteristic of circular motion. The next is changing or variable velocity. Changing or variable velocity. Because when you say circular motion, it's a motion like this. So let's say that an object is trying to go around this circle. The speed is constant, but the velocity is changing. Why do we say that the speed is constant? And why do we say that the velocity is changing? Because velocity is a vector quantity. Velocity is answering to direction. And at every point of this motion, the direction is changing. Do you understand? So velocity is answering to direction. Why speed is not answering to direction? Do you understand? Number 3, it has what we call centripetal acceleration. Centripetal acceleration. So if these 3 things happen at the same time, we say that that object is undergoing what? Circular motion. So what is centripetal acceleration? Since centripetal acceleration is experienced by any object undergoing a circular motion, and it is always directed towards the center of the circle. Now, this centripetal acceleration has a formula. A is equals to V squared over R. Formula 1. V is our velocity, and R is our radius of what? Around the circular part. Now, from here, we can quickly enter centripetal force. This centripetal force is defined as the force that keeps an object moving along the circular path. Any object that is going along the rectangular path, the force that is keeping it on that track is called centripetal force. Do you understand? I remember from Newton's law of motion that F is equals to ma. So that means that this centripetal force is going to be what? F is equals to m. Remember that A is what? V squared over R. So the formula for centripetal force is what? mv squared over R, equation 2. Is that clear?
Yes, sir.
Now, there is a formula that connects series of stuffs together under centripetal force, under circular motion. As we see them, we would also be answering them. So let's start answering questions relating to circular motion. So the first question says, an object of weight 150 Newton moves with a speed of 4.5 meters per second in a circular path of radius 3 meters. So I'll just write out the parameters. I'll read the question and write out the parameters. So example 1. An object of weight, so the force is 150 Newton. This force is weight force. Moved with a speed of, that's the velocity, 4.5 meters per second in a circular path of radius r is 3 meters. Calculate its centripetal acceleration and the magnitude of the centripetal force. So we need A, which is V squared over R. And we need F, which is what? mv squared over R. Now, from here, we can calculate the centripetal acceleration by just saying 4.5 divided by what? 3. 4.5 squared divided by 3. And you press the calculator, you have 4.5 times 4.5, 20.25, then divided by 3. That's 6.75 meters per second square. Here, we need mass. To get mass, we can use this one because this one is weight. Weight is equals to mg. So you can get your m because your g is a constant 10. So weight will just be, mass will just be weight over g, which is 150 over 10, which is 15. So our force is just going to be 15 times the A that we've gotten before, 6.75. And that would give us what? Times 15. That is 101.25 Newton. Is that clear? Good. Now, another example. The question says, a stone of mass 500 gram tied to a rope 50 centimeter. So let's write our parameters. A stone of mass 500 gram. A stone of mass 500 gram tied to a rope 50 centimeter long. That's going to be the radius. You have a stone. You now tie a rope around it. That rope is 50 centimeter long. You now roll it. This point that you're rolling it is going to form a circle like this. Do you understand? The stone is going to go like this. No, not like this. It's going to go such that at some time the stone will be here, at some time the stone will be here, at some time the stone will be here. Do you understand? This is the center. So you can see that this 50 centimeters is our radius. Do you understand it? So this center is where you are holding it and you are rolling it. So the stone is going to be touching the circumference like an edge, like a circle. Do you understand? So I just want to show you that the length of the rope is going to be your what? Your radius. Do you get it? Is that clear, guys? Excellent. So a stone of mass 50 gram tied to a rope 50 centimeter long is whirled at an angular velocity of 12.0 rad per second. I'll talk about that. Angular velocity of 12.0 rad per second. Calculate the centripetal force. We have to find F. Now, there is a formula that connects angular velocity. So just like we have velocity, we have angular velocity. Angular velocity is used when we are talking about circular motion. And there is a formula that connects linear velocity to angular velocity. So, and the formula is V is equals to WR. This one is WR, angular velocity, W. This V is our normal velocity. This W is our angular velocity. And this R is our radius. So again, you need this formula. V is equals to WR. Is that clear? Now, this our angular velocity. It is also equals to 2 pi F. There's another formula that you need to hold. We are going to use this formula when we get to simple harmonic motion. So that's formula number what? Formula number 4. This formula number 3. This formula number 4. Is that clear? So I've given you guys the formula that connects our linear velocity. That normal velocity that you know, normal velocity that is equal to displacement over time. It is connected to angular velocity. This angular velocity has to do with circular motion. Do you understand? Multiplied by the what? By the radius. So the unit for angular velocity is rad per second. So this question says, a stone of mass 500 gram tied to a rope 50 centimeter long, is turned or whirled at an angular velocity of 12 rad per second. Calculate the centripetal force. Now let's start from converting this guy from gram. We don't want gram. We want kilogram. So our mass is going to be 0.5 kilogram. And also our radius, we don't want 50 centimeter. We want meter. That's 50 divided by 100. That would be 0.5 meters as well. Now we have our angular velocity to be 12.0 rad per second. Now the question wants us to find centripetal force. But we know that centripetal force F is equals to what? mv squared over what? Over r. But this v squared is equals to angular velocity r. So we just say that our F is going to be equals to mass times this r squared over r. Then we can solve. We can put our parameters now. So F will be equals to mass times angular velocity squared, radius squared over r. This r will cancel one r. So finally, we can say our mass 0.5 times angular velocity, which is 12 squared times radius 0.5. If you press all of this in the calculator, you're going to get your centripetal force. Very simple. Just know the formula. 0.5 times 12 times 12 times 0.5. That gives us 36 Newton. Is that clear?
Yes, sir.
Excellent, excellent. Question. It says a force F is required to example 3 now. We'll solve 2 examples, then we'll go to simple harmonic motion. A force F is required to keep a 5 kilogram mass moving. Mass 5 kilogram. Remember, that's how I like to solve my question. I like to write out my parameters. A force F is required to keep a 5 kilogram mass moving round a cycle of radius. Radius is 3.5 kilometer at a speed of, that's your velocity, 7 meters per second. What is the speed if the force is tripled? So you have to calculate the speed if F is tripled. This is the question. Now, the question is very simple. Let's calculate the first when it has not been tripled with all these 3 parameters. mv squared over r. That's 5 times. But this one, v squared, that's 7 squared over r. We can't use this because it is kilometer. We have to use meter. So what do we do? 3.5 kilometer. Yes, you have to change the meter. It appears that the question is actually 3.5 meter. I wrote kilometer instead of meter, sorry. But assuming that it is kilometer, you would have used 3,500 meters. Do you understand? You have to convert it to meters. So this will be 3.5 meters. Then you solve the question to get the centripetal force. 5 times 7 times 7, then divided by 3.5. That gives us 70 Newton. But this force is tripled. That means that the force becomes times 3. The tripled force is going to become 210.
210.
Now we are now asked to find the velocity. So we say 210 is equals to the mass is still 5 times v squared over r, which is 3.5. So let's cross multiply now so that we can solve for v. So 210 times 3.5 is equals to 5v squared divided by 5 divided by 5. So v squared is equals to 210 times 3.5 divided by 5. So root answer, that's 12.12. I've gotten the final answer of 12.12 meters per second. And that's the answer. This question is a jam question. This one we solved. UTME question. So another example 4. If a wheel 1.2 meter in diameter rotates at 1 revolution per second. Good. I'm going to explain this. If a wheel, let me write the question. 1.2 meter in diameter rotates at 1 revolution per second. Calculate the velocity of the wheel. Now, remember I told you that velocity is related to angular velocity with the formula V is equals to angular velocity R, right?
Yes, sir.
Velocity itself is displacement over time. You see angular velocity, it is equal to our angle in rad over
Yes.
time. Is this clear now? Now, this our angle here is now equal to 2 pi. Now, the first thing we are going to do in this question is that the question says if a wheel 1.2 meter in diameter rotates at 1 revolution per second. So what we have to do is we have to first convert our angular velocity, which is in 1 revolution per second, to radian per second. Because we do not use the revolution for calculation, we use rad. Do you understand? How do we then do that? 1 revolution is when the object has gone round the circle. That's 1 revolution. And at that point, our theta is equals to 360. The whole angle. Do you understand? Which is equals to 2 pi rad. Do you understand?
Yes, sir.
So since it is 1 revolution per second, we say that we have 2 times 3.14159, which is going to be approximately 6.28 rad per second. That's our angular velocity. Do you understand?
Yes, sir. Yes, sir.
Good. Now, we've gotten our angular velocity to be what? 6.28 rad per second. Now, let's get our radius. If a wheel 1.2 meter in diameter, and remember that diameter is equals to 2 radii, which means that 1 radius will be diameter over 2. So our radius here will just be 1.2 divided by 2, which is 0.6. With this, we can get our what? Our velocity, linear velocity. The question is silent, so it just says velocity. Don't ask me that, is it angular velocity? No. We all know velocity. It is linear velocity that the question is asking. Do you understand? So if it is angular velocity, the question would have stated explicitly that find angular velocity. But because the question said velocity, we should know that we are supposed to find what? Linear velocity. So we have to now use the formula V is equals to angular velocity R, which is 6.28 times 0.6. times 0.6. So that gives us a 3.768. 3.768 meters per second. Is this correct? So I want to believe that with all these formulas I have done, I have dusted all the formulas that you can come across under harmonic motion, under circular motion. So let's just read the questions and answer this question, the theoretical parts. The calculation parts, we'll just solve them very, very fast, not something difficult, so that we can move to simple harmonic motion. I want to start simple harmonic motion today, sure. So question number 1, that's very simple. If you're in this class and you don't know question number 1, that's wrong. The force required to make an object of mass m traveling with velocity v turn in a circle of radius r is what? mv squared over r. Option A. 2. An object moves with uniform speed round a circle. Its acceleration has... I've said this today in the class, but I didn't state it explicitly. For an object that moves with uniform speed around a circle, its acceleration is going to have 2 things. That's what they want to test. First, constant magnitude and constant direction. So we are testing the value of the acceleration, that's its magnitude, and the value of its direction. Now, if it is moving around a circle, it is going to have constant magnitude, but the direction is going to change. The direction will not be constant. Lie. So option A is wrong. Why? I drew a circle and I explained to you guys earlier. If we have a circle like this, an object is trying to move around this circle, it has to maintain a particular speed. Otherwise, it's going to what? It's going to slide off. So we gotta make sure we maintain motion turn. If you have ever seen people going around a sharp corner, you see that they don't walk in conjure sharp corner. No, you have to be very, very careful and calculative. Do you understand? Oh, need tenoju. Because if you tenoju, you just go off course. So you maintain. Yakubu will manage. You keep going, you keep going, you keep going, you keep going, you keep going. So the acceleration is going to be constant. But the direction is changing. The direction here is different on the direction, it's different on the direction, it's different. So you can see that the direction has changed at every... In fact, once you go again in another 1 meter, the direction has changed. Another 20 centimeter, direction has changed. So at every point, direction is changing. That's why we say it has what? Constant magnitude of acceleration, but varying what? Direction. So that's correct answer is what? B. Constant magnitude and varying direction. Varying magnitude, no. Varying magnitude, no. That's correct. Question 3. Which of the following is true of a particle moving in a horizontal circle with constant angular velocity? With reason, why did you choose B? Now, if you have followed us from the start of this course, you would have known the correct answer from the start. If that is like from the start of quantity that we started in physics. Now, they are checking between energy and momentum. They are dragging between energy and momentum. Abi, for question option A, is between energy and momentum. It says the energy is constant, but the linear momentum varies. In energy, I told you guys that energy is the same. Energy is not, it's a scalar quantity. So when we check with energy and momentum, I told you guys explicitly from the start of this course, energy and work are scalar quantity. They don't change. Sorry. What I mean by they don't change is that they are not affected by direction. So when this question says the energy is constant, we'll think about it like, yes, the energy will be constant, truly. Do you understand? From where we are starting. Momentum is a vector quantity. It changes with direction. Direction will affect it. And when an object is moving in a circular path, energy is there. That energy is not going to change because normal, it does not even have direction. So the energy will be the same. If it has momentum, that momentum is going to be changing at every instant. Why? Because that momentum has what? Direction. So me, I'm going to pick option A as my correct answer first. But let's see the other options. The linear momentum is constant. No. Momentum will not be constant. Why? Because it has direction. And we already know that with a circular motion, if any of its quantity have direction, that quantity will not change. Sorry, that quantity will change. It will not be constant. So linear momentum is constant is incorrect, but the energy varies. Incorrect. Energy is a scalar quantity. If it occurs in circular motion, it is going to be constant. Why? It does not have direction. Option C, both energy and linear momentum are constant. No. Energy is constant, linear momentum varies. That's the correct one. Option D, the speed and the linear velocity are both constant. No. Speed is constant, but linear velocity is not constant. Why? Linear velocity has direction. Hey, Koye.
Oh, yeah.
Good. Question number 4. Its velocity is constant. No work is done on the body. It has constant acceleration directed away from the center. The centripetal force is directed towards the center. Which combination of the above is true of a body moving with constant speed in a circular track? You can see, I started my class today by telling you this question number 4 first. So, tell me the correct answer, please. Its velocity is constant. I don't know. Is velocity constant for circular motion? Remove it. No work is done on the body. Yes, no work is done. How do we know? The work is the same. Remember, under motion, normally, if a body maintains a particular speed, it is as if it is not even moving at all. Do you remember? So if work is constant, it's as if we did not do any work. I'm a common report card there, Wale. A boy came home with his report card. SS1, you see, first term, 100. Second term, 100. Third term, 100. SS2, 100. First term, second term, 100. Third term, 100. SS3, 100, 100, 100. When the boy wrote WAEC, A. When he wrote JAM, 380. That kind of boy, you just be looking like, this book is not even challenging to him. You will not see the boy as doing anything special. Do you understand? Why? Because normal. You have seen that the boy is a very brilliant boy. Do you get it? So you will not see the boy as doing anything special. Because normal, the boy is brilliant, is a brilliant boy. You can even go to the school, share them form in Sheba, share in carry by. Do you understand? So you'll be asking those questions because you can see that effort. It's a constant effort. So when something becomes constant, it becomes like it is a normal thing. You have not seen people that they will come and you give them 1,000, so they give them 1,000 tomorrow. Give them, the next day, if you not give them 1,000, they will think of you as a bad person. Normal. You're not even supposed to give them to start with. You are helping them, normal. But the day that you fail to give them, they will not even give you excuse. They'll just say that, unshawani. Because they have felt like it's a normal thing for you to give them the money. You understand? So when something becomes constant, it becomes a norm. So no work done is done because the work is already constant. So we are not saying it as an extra work. Assuming we now say an extra work, we now say, hey, when the boy comes home now, I'm talking about 100, when now comes home and gets C, the parents, the mother and the father will say, "Wahala ti ṣẹlẹ̀. Something is happening. This boy is not reading again." Do you understand? They now start checking what's going on. Is it that the exam is hard? Is it that you are not reading again? They now start checking for preventive measures. So number 2 is correct. It has constant acceleration directed away from the center. Its acceleration is not constant, though. It varies because acceleration has what? Direction. Direction is changing. So this one 2 is wrong. The centripetal force is directed towards the center. That's correct. It's directed towards the center. So 2 and 4 are correct. When I told you guys that theoretical physics is difficult, you think I'm joking. You have to think. You have to think. A particle in circular motion performs 30 oscillation in 6 seconds. Its angular velocity is... I think I gave you the formula for this one, Abby. Did I?
Yes, sir.
What was my answer? You said yes, sir. You said yes, sir. So what's my answer? Yeah, sharp. Oh yeah. Don't dull me, please. Somebody to wipe your tears. I'm seeing answers that are different from what I think. Okay, number 5. For number 7, D. Okay, people are already solving number D. So I think that we didn't actually solve this kind of question for question number 5. It says a particle in circular motion performs 30 oscillations. So what do you mean by oscillation? What do you mean by the word oscillation? So oscillation is going back and forth. Vroom, 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 vroom. So a particle in circular motion performs this oscillation 30 seconds. Do you understand? Sure. So we need to get from this oscillation here, because we have the oscillation with respect to time, we can get the frequency. Frequency, when we say frequency, is the number of oscillation per seconds. Do you understand? So we can get the frequency of this particle by saying N/T. I'm already giving you the formula some of the formulas that we'll be using in simple harmonic motion. So when we say N/T, number of oscillation is 30, and the time for that oscillation is 6. That gives us what? 5 hertz. Now remember that I told you guys that our angular velocity is 2 pi f. So it means that our angular velocity is going to be what? 10 pi. If you put f there, do you understand? So which the answer is option A, 10 pi rad per seconds. You leave the answer in with respect to what? With respect to pi. Is this clear? Yes. This formula again, F is equals to N/T. Very important. Hold it. We are going to use it under wave. I hope we get to wave before we finish the class. Before jump. Lot of questions. Only if you guys will not sleep again. And you guys are lazy. Someone said the question is not clear. A particle in circular motion performs static oscillation. I told you guys that oscillation means back and forth. So it performs 30 back and forth in 6 seconds. There is a quantity in physics that measures the number of back and forth a person does in a particular time. That quantity is what? Frequency. The frequency is how many back and forth number of oscillation can we have in a particular time. So frequency is what? Number of oscillation over time taken to make that oscillation. Now, let's get the frequency. The frequency is going to be what? 30 over what? 6, which will give us what? 5 hertz. The unit for oscillation is for frequency is hertz. Is that clear? Now, I gave you guys a formula here. W is equals to 2 pi f. Where is it? I W is equals to 2 pi f now.
It's up.
Up, eh? I didn't write it. Yeah,
That
this
is
one.
it.
Yeah.
Done.
Good. So this f now, we've got an additional formula for f is what? N over t. It has so many formulas, though. F can also be 1 over t, capital letter T, though. This t now is not time. This t is different from time now, it's period.
Yeah.
When we get to super harmonic motion, we'll talk about it. Now, we've gotten 5 hertz, but the question wants us to find angular velocity. So the formula that connects angular velocity with frequency is what? 2 pi f. We have f already to be 5, so we just do what? 2 times 5, 10 pi. So it's 10 pi. And the unit of angular velocity is what? Rad per second. So that's why we pick option this, A. 10 pi rad per second. Is that clear? A piece of stone attached to one end of a string is, how do you pronounce this word? Don't break my teeth, please. Is whirled round in a horizontal circle, and the string suddenly cuts. If you laugh at here, you laugh. Suddenly cuts. The stone will fly off in a direction. Very good. I love this question so much. Oh, yeah. What's the answer to question 6? With proof, proof from the Kitab and Sunnah. B. Rakib, what's your proof? Give us an hadith that backs it up. Faisha, don't say anything. Yes, now, Kitab and Sunnah. Okay, so the answer is tangential to the circular path. That's the answer. That's the answer. If your car suddenly gets stuck in Potopoto, you're now raising it. If I want to leave the Potopoto, before those area boys and people that used to call a Gbandubu, before they come and catch you there, I should give them something. You have to go fast. Otherwise, if they help you to push the car, if it is still somewhere like Ede, Ondo, is still very good. If it is in Lagos, if last man catch you, you're gone out. So what do? You shall be raising it. Engage the faster yet. This is what they reverse FPC J1, FPC J2, FPC neutral. That tire is going to be scattering the Potopoto. Is it parallel? Is it perpendicular? No. It's going to be tangential to the circular part. Do you understand? How come so tangential to the circular part. Towards it, no. So it's nobody knows the pattern. That's what tangential means. Nobody knows the pattern. Do you understand? It's not perpendicular, it's not parallel, it's not towards it. No, it's tangential to the circular part. Mala Misha, you have a question. Go ahead, please.
Yes, I have gotten it.
Good. Now, 7. A car of mass this goes round the circular curve of radius this at the speed of this. The magnitude of the central force of the car is. We've done a question like this, so we don't need to go over it again. The formula is just F is equals to mv squared r. You get it. Question 8. A force F is required to keep a mass this around the circular path. The force is triple. We've done this question. Question 8. We've done question 8. I told you guys that it was a jam question. An object of mass 2 kg moves with a velocity of around a circle. I'm going to say enough force on the object. I've already done this one, but this one too is simple. Is F is equals to m squared r. F is equals to mv squared over r. Sorry. An object moves in a circular path of radius d with a speed of what's its angular velocity? Did you do this question? Question
Yes.
10, did you do it? Have we solved it?
Yes, sir.
Mhm. Of radius this. So this is r with a speed of this is the v. What's its angular velocity? V is equals to wr divided by r divided by r. So w is equals to w. Sorry, yeah, w is equals to v, which is 1 over 0.5. So what's your answer? 1 divided. What's that? One divided by 0.5. That gives us 2 rad per second. Option C. Question 10, option C. That's correct. A stone Q is tied to a point P vertically above Q by an elastic string of length 2 meters. How high does the stone rise when the string is inclined at an angle 60 degrees to the vertical? Wow. Question 11. What do we do here? See how people are plenty in class today. Yorubas will say Ojoli Rondole. I can't remember the last time we had a large number of class like this. In fact, we are up to 17 today. I saw 17. I think some people left, some people joined again. Mashallah, mashallah. Free class, there's supposed to be like 100 students, 50 students. Free class. We are more than 100 on the group. I realized that some people are just there to even come and see what we are doing. Okay, let's think about this stuff. A stone Q is tied to a point P, vertically above Q, by an inelastic string. Okay, let's relate it. A stone Q is tied to a point P. A stone Q is tied to a point P, vertically above. A stone Q is tied to a point P. How do you know that it's 1 meter? Explain to us. Vertically above Q by an inelastic string of length 2 meters. Okay. How high does the string rise when this? How high does the stone rise when the string is inclined at an angle 30 degrees to the vertical? Okay. The string is vertical. We know that one, Abby. The stone rises upwards. The only thing we have is these 2 meters. Oh, and 60 degrees. So 3 meters, 3 meters, 1 meter. It will be 2 minus 2 cos theta. This one is from work done. This question is not related to simple to circular motion, but that's the answer anyways. So 2 cos theta is 60 degrees. So when you do cos 60 degrees is supposed to give you 0.5. So 2 times 0.5 is 1. 2 minus 1 is 1 meter. That's the calculation way, but I'm sure that there is a no solution answer to it, but I can't interpret this in my head at the moment. That's why I'm leaving it to calculation method. Question 12. A ball attached to one end of a string moves anti-clockwise around a circle whose center is this. If the string suddenly breaks off when the ball is at a point P, along which of the following path will it move? So that question that we solved here, question that we said is going to move tangential. This is the practical. So what is tangential now? Which of these is tangential? This one is along the center. So this one is not tangential. No. A is not tangential because you can already see. It's not going to go inside again. It's not possible. And it's not that it's going to be cuff like this. Cuff. No. Even if, let's assume that you have a tire like this. You are now rolling the tire like this along this path. Do you understand? So this one is the correct answer. It's going to go tangential. This is correct answer B. Do you understand? So tangential is option B. Satellite revolving around the Earth is kept in its orbit by A, centrifugal force only, B, centripetal forces only, C, centripetal force and frictional force, B, centripetal force and centrifugal force. So I already explained to you guys that for an object to be balanced, two forces must act at the same time to keep it in balance: the upward force and the downward force. The same thing is applicable for objects in circular motion. The force that is acting inside, that is keeping it along that circular path, there is a force that is keeping it along that circular path that is acting inside. That one is called centripetal force. There is now an equal force that would balance that one, that would act outside. That one is called centrifugal force. Do you understand? In chemistry, there's a separating technique that is called centrifugation. You can think of that idea from centrifugal force. It has to do with spinning test tubes to separate particles. La hawla wala quwwata illa billah. Are you with me?
Yes, sir.
That to do with spinning what? Spinning test tube. You put up sorts of different densities, very close different densities. So I have question 14. If the wheel 1.2 meter in diameter rotates at 1 revolution per second, what is the velocity of the wheel? We want to do question 14. No be so. We have solved question 14 itself. We have solved it. Okay, so let's move to simple harmonic motion quickly. So on simple harmonic motion, there are a couple of stuff that we need to learn. Under simple harmonic motion, can we start simple harmonic motion, please? So some of the things we need to learn is the idea of the formulas that we need under simple harmonic motion. So I'll be very, very fast. I'll quickly combine the theoretical and the formula part of simple harmonic motion. Is that okay? Now, a body is said to undergo simple harmonic motion if and only if, number one, its acceleration is directed towards a fixed point. Acceleration. If you go to Jan Bremings combined simple harmonic motion and circular motion. Do you understand? So you might think that those questions are complex. It is actually simple harmonic motion. It's not 100% circular motion. Do you get? The past question here I'm using, I have screened out all the questions that are simple harmonic motion. Do you understand? I have screened them out. And the
Yes, sir.
circular motion, I brought them out. Don't worry. We'll solve questions that are simple harmonic motion. So when we now solve them, you now feel like you still have more questions that you want us to solve. Don't worry. We'll solve it too as well. I'm not running from question.
Yes, sir.
I've most likely seen those questions you are saying that are difficult before too. So simple harmonic motion, its acceleration is directed towards a fixed point. That's why we say it is simple harmonic motion. Number two, its acceleration is directly proportional to its distance from the point. Now, when we now talk about simple harmonic motion, there are a couple of things that we also like students to know when we talk about simple harmonic motion. One of which is some basic terms that we talk about under simple harmonic motion. These two things now, I've just given you the definition of simple harmonic motion. When you define simple harmonic motion, assuming it is YX student now, we define simple harmonic motion for them as a special type of periodic motion of a body or particle whose acceleration is always directed towards a fixed point. You can see. And directly proportional to its displacement from that point. That's the definition of simple harmonic motion. Do you understand? And JAM is going to test your understanding of these two things. Do you really understand these two things? So from this definition now, we say that A is directly proportional to Y. Why am I using Y? Y-axis. So therefore, we say A is negative angular velocity square Y. We'll get there. So let's look at some terms related to simple harmonic motion. Number one, amplitude. These things, I want you guys to not forget them because we are still going to revisit some of them when we get to wave. After simple harmonic motion here now, I want to go to electricity. After electricity, I will go to, what is it called? I will go to its energy, then we'll go to wave. So that's how we'll do it. So amplitude, when we say amplitude, it is the maximum displacement of a body or particle from its position or equilibrium. Amplitude is the highest vertical distance obtained by an object. Do you understand? Do you get that? So it is denoted by A and measured in meters. Period, time, is the time taken for a particle or body to make a complete oscillation. It is denoted by capital letter T, but we call it period. It's different from that time, small letter T. But they are somewhat similar also. Frequency, you've met frequency. You've met angular velocity. You know what displacement is. Abi? Maybe so.
Nothing.
Good. So this period T now is equal to time over number of oscillation. Why frequency is number of oscillation over time. So the two of them, we can say they are word and opposite. That's why we relate frequency as 1 over capital letter T or capital letter T as 1 over frequency. So these guys, they have this kind of relationship where N stands for number of oscillation and small letter T stands for time in seconds. Capital letter T stands for period in seconds as well. F stands for frequency. Is that clear? Now, quickly, let's revisit from formulas. Angular velocity is equals to what? Displacement over time. Angular displacement. This thing here is angular displacement. Number 1. Formula number 2. Our velocity is equals to angular velocity multiplied by what? Radius. Or angular velocity multiplied by what? Amplitude. It also works like that because amplitude is what? Highest vertical displacement. Remember, so it's length, radius. Formula number 3. Our angular velocity can also be expressed as 2 pi f. Remember? So if you make f stand alone, f is going to be equals to what? Angular velocity over what? Over 2 pi. But remember that t and f, they have a relationship whereby anything that t carry up, anything that f carry up, t will carry it down. That means that we can say that our t will be equal to bring 2 pi up, then bring w down. Do you understand? Is that clear? Now, another formula that is important under harmonic motion is our angular acceleration. Our angular acceleration is equals to the square of angular velocity multiplied by r. This was the formula I wrote here before. But because our r can also be our a, we can say that it is angular velocity multiplied by what? A. So both are correct. Let's use capital letter A to separate it from acceleration. Do you understand? Now, there's a formula that now links, because the way we have velocity, we have angular velocity, W. Let's start from the basic, very basic. We have displacement, D. We have angular displacement, theta. We have velocity, V. We have angular velocity, W. We have acceleration, A. We have angular acceleration, alpha. There's a formula that links acceleration and angular acceleration as well. That formula is formula number 5, which is A is equals to alpha R. Is that correct? Is that clear? So all these ones are linear motion. Yeah, linear motion. These ones are circular motion. Can you see? Parameters. Displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. Do you get it? The last formula that I would look at is the formula that links, that shows the relationship between velocity as our this and square root of a squared minus x squared, where x stands for our normal displacement and a here stands for our amplitude. So let's stop here. Every other formulas are things that we know before. Don't forget that 360 degree is equals to 2 pi rad, because sometimes you have to convert revolution to rad. Is this clear? Let's take some questions that would make us use these formulas, and we continue to want to quickly say something about simple pendulum. Can we?
No.
Why, Ryan? Still writing? So let's see example number 1 under this. The period of oscillation of the particle executing simple harmonic motion is 4 pi seconds. Period. Is what? 4 pi seconds. If the amplitude of oscillation is 3 meters, the amplitude A, which can also be R, remember, is what? 3 meters. Calculate the maximum speed of the particle. You have to calculate V. Now, is there a formula that links C and R together? Let's talk about the formula that has period. This is 1. This is 1. This is 1. And I think this is the one that we can use so that we can get W. Once we get W, we can use V and R and W to solve V. So that formula that says T is equals to 2 pi over W. From it, we can get W. T is 4 pi. So we say 4 pi is equals to 2 pi over W. So let's solve for W, cross multiply. 2 pi is equals to, 4 pi W is equals to 2 pi divided by 4 pi divided by 4 pi. That's what we want. We want the pi's to cancel. So 2 in 4 is 1 over 2, that's 0.5 rad per second. So angular velocity is 0.5 rad per second. So we just need to calculate the linear velocity. Other simple harmonic motion, formula is equal. So you just have to be smart. Formula is equal. In fact, that's why it's not advisable to even teach this course for SS1 students. I don't like to teach it in SS1 at all. Simple harmonic motion, no. Because all my double motion they will just be looking at kilo day. And all these formulas I gave you, they have proofs, though, but because proof is not our concern, that's why we are not doing their proofs. So we are just doing the best theorem. So V is equals to angular velocity R. So we need to get V. So angular velocity is 0.5 multiplied by our R, which is 3. So 0.5 times 3 will give us 1.5 meters per second. And that's the answer. Example 2. A body is rotating in a horizontal circle of radius 2.5 meters with an angular speed of W is 5 rad per second. Calculate the magnitude of its radial acceleration. We have to find A. What formulas join acceleration, radius, and angular velocity together? That's the formula here. Staring at you, saying, Rakib, look at me. Rakib, do you remember me? A is equals to W squared, 5 squared times R, 2.5. So that's 25 times 2.5. 25 times 2.5. That gives a 62.5 meters per second square. Last but not least, example 3. Rahima, with all these formulas that I've given now, those questions that you think they are hard, what do you think now? She's still here?
I will go back to it. Sir?
You have to check again, Abby.
Yes, sir.
Okay. A particle moves in a circular orbit of radius 0.02. Radius. Just right. Don't you see? Cover your eyes from rubbish. That orbit is rubbish. You just be thinking, call orbit in school, orbit. Man, smart did not teach us orbit. You now start raining courses. Focus on what is important. Dear, what is important here? Take your radius and leave. If the speed of the particle is 0.88 meters per second, that's speed, V. 0.88 meters per second. Calculate the frequency. You have to find F. So a formula that links V, R, and F together. Do we have a single formula like that? I don't think so. You have to get W first because we know that there's a formula that links W to VR and a formula that links W to F. So let's get W first from VR. So W is going to be equal to V over R. That will be 0.88 over 0.02. Don't stress your life and say you want to use your head to do it. There's a calculator. 0.88 divided by 0.02. That gives you 44. 44 rad per second. You have to get F. And F is equals to W over 2 pi. No be so? Not so. So just do 44 over 2 times pi. So 2 in 44 will be 22. Just do 22 divided by 3 points, whatever. 22. 22. 22 divided by 3.1427 hertz. That's the answer. Is that clear, everybody? I've not uploaded the question on my folder. That's why I'm just picking the questions randomly from. But we are still going to do the questions. Here I have questions I have on simple harmonic motion is 18 questions. And we are going to look at all the 18 questions in the next class. But I want to give you everything that has to do with theory so that I can know that I'll just focus on the questions and maybe whatever I miss in the theory when we see a question, then I'll just say it. Now, let's quickly go to simple pendulum. I want to stop on questions. I want to move to another aspect of simple harmonic motion. I just introduced you to simple harmonic motion, the parameters, stuff that are important, and all of that. I give you the formulas. So now, we have discussed the extra class. We have discussed even extra class will tire you, sir. The motion of a simple pendulum is a typical example of simple harmonic motion. All the equations that I gave you above, you can use it under simple pendulum. But there is a specific formula for simple pendulum. That formula is the formula for its period. The period of a simple pendulum is 2 pi square root of L over G. T is the period. L is the length of the pendulum. And G is our normal G, that guy that you know, acceleration to gravity, in meters per second. This is equation 1. There's problem. When you see equation 1, you know that there's problem. There's problem, yes. Now, you see the period of a simple harmonic motion and its length. We can compare them with another period and length of the same or different pendulum in the same location. The only distinct factor that we can use to distinguish between them is the length of the pendulum. Now, this guy here, let's square everything. So I'm going to do t squared and 2 pi square root of L over G squared. When we square, we have t squared is equals to 2 pi squared. That's 4 pi squared L over G. You know that this square root will just escape. But these two guys will take the square. That's why 2 becomes 4 and pi becomes pi squared. Do you get it? Is that clear?
Yes, sir.
Good. So this is equation 2. Now, we now want to do some little bit of small manipulations here and there so that we can get some very important stuff from here. I want to bring L to this side of the equation. So I have t squared over L is equals to 4 pi squared over G. Is this clear? You see this 4 pi squared over G is a constant. This 4 will not change. We already know what G is. G is G, acceleration to gravity. And pi is a constant. Do you understand? The only thing that we need to know is the period and the length. Do you understand? Length of the pendulum. Every other thing will remain. So this one is a constant. And what do we do to constants? We can just decide to say, okay, if we are relating the same pendulum, if you are relating two same pendulums together, we can take up the constant and just say t square 1 over L1 is equals to t square 2 over L2. Because this one, the value will not change. It's only this one that the value will change. This one as it is, we can get the answer. It is 4 times 3.142 squared over 10. Do you understand? But the only thing that will change, that will be given, is the period and the length of the pendulum. Do you understand? Now, let's arrange so that the t's will be in one side and the L will be in one side. This one. So we can cross multiply and say T1 squared L2 is equals to T2 squared L1. So take L2 to this side so that to cancel here. Then bring T2 squared to this side. So you have the T1 squared over the T2 squared is equals to L1 over L2. So if you take square root here, you have T1 over T2 is equals to square root of this side too. You know, these squares will cancel out the square roots. So the square root will just go to L1, L2. This is another formula 4. And this is the one that we use majorly. Do you understand? There is a reason why I went in depth to show you that T1 over T2 is equals to square root of L1, L2. I could have given you the formula, but I initially and purposefully showed you where we are going and where we are coming from. Is that clear? Let's see one question on this simple pendulum jargons. And we can now see if we can do energy before we now stop the class, so that we know the next class is just to just come and put question. We know we are done with all the explanation on simple harmonic question. And this is not all the explanation. You need to still go and read your textbook. There are still some things that I just left because I felt like these ones are the important stuffs. But if you go through a good secondary school, all those things that I left, you know them. Now let's see a question. A simple pendulum example 1 under this one. 0.64 meter long has a period of 1.2 seconds. Calculate the period of a similar pendulum. So let's just write T1 is L1, a simple pendulum 0.64 meter long. So L1 is 0.64. Has a period of, so the period T1 is going to be what? 1.2 seconds. Calculate the period of a similar pendulum. So we have to find T2 now, unknown, period. That is 0.36 meter long. So L2 is going to be 0.36 in the same location. Don't forget. That's the time you can use this formula. So formula is T1 over T2 is equals to square root of L1 over L2. So what is T1, T2? Our T1 is 1.2 over T2 is equals to square root of L1 0.64 over 0.36. So let's do that. 0.64 divided by 0.36 gives this square root 0.64 divided by 0.36, 1.77, square root of 1.78, square root 1.334. So T2, so we say 1.2 over T2 is equals to 1.34. Happy? 334 over 1. So cross multiply, T2 will go here. So 1.2 is equals to 1.334 T2 divided by 1.334 divided by 1.334. So T2 is equals to 1.2 divided by 1.334. That gives us a 0.9 seconds. That's the period of the second guy. Let's see another one. The way Jam loves to bring out the question, Ganga. Example 2. I'll write this question. A simple pendulum with a period of 2.0 seconds has its length doubled. No, we already approximated it. If you check, it is actually 0.988 something. So 899. So they are present to 0.9. It depends on the option actually. I think 0.9 is the option. That's why I present to 0.9 seconds. Its length doubled. Its new period is A1, B 1.41, C 0.35, D 2.83, E 4.00 seconds. So a simple pendulum with a period of 2 has its length doubled. So period is 2, T1 is 2. The length L1 is L. So we have to find T2, which is unknown. But L1 is L. But L2 becomes what? 2L, doubled. Do you get it? In fact, you can say L1 is 4 and say L2 becomes 8. Nothing happened to you. Still the same thing. Do you understand? You can say L1 is 1 and L2 becomes 2. Do you understand? You can give it the value. Its length doubled. So you can say before the length was 5. So double of 5 is what? 10. You can use that value. You get your answer. So just do T1 over T2 is equals to square root of L1 over L2. Very simple. So T1, T2 is what? 2 over T2 is equals to square root of 5/10. So let's do 5 divided by 10. So root of 0.5 is 0.7. So we say 2 is equals to 2/t2 is equals to 0.7071. So 2 is equals to 0.7071 T2 divided by 0.7071 divided by 0.7071. So our period 2 is going to be 2 divided by 0.7071. That gives us a 2.82. Can you see the answer? 2.83. And that's the answer. Option D. Is that clear? So even if you like, you use that idea if you like, so you can give it value, doesn't really matter. Is that clear?
Yes, sir.
Now, energy of a simple harmonic motion now. That's the last place we are going to stop today. And in our next class, we'll just come and solve questions. I believe that by that next class, you guys would have read about simple harmonic motion. The energy of simple harmonic motion. This energy is derived when the motion of a loaded spiral spring is considered. Sometimes we used to load spiral spring. We now calculate the simple harmonic motion of that loaded spiral spring. So the following equations that I would write now, and the ones that I've given you before, we can use them to solve questions relating to what? To that. Let's stop here. Let's continue from the next class, inshallah. Is that okay, guys?
Please, I don't get the question. No, please, can you explain again?
Which one? Which part? I didn't solve any question
Everything.
again, no. Everything. That means you go and watch the video.
Everything. That means you
You
can't
go
watch
and
the
watch
video.
the video.
The
That's the last
example
one.
that you just
Already? This, you mean this one, this simple pendulum question?
yes, sir, yes, sir.
Mhm. Go and watch the video. If you watch the video and it's still not clear, let me know. Is that okay? Let me know in the next class. But I think that the best thing is that you watch the video. It's almost Maghrib time here. You know, Maghrib is very fast here. So, my students, continue in the night, please. What time is the class?
What time is the class? 10 o'clock.
No, I didn't say 10 o'clock.
No, I didn't say 10 o'clock.
Chill.
9 o'clock.
So, we'll start at 9, inshallah. And we'll finish when I'm tired.
Inshallah.
All right, please, let's
Now,
do the copy of the recording can stop.
okay.